If there's billions of agents and they each need their own cloud, what does that look like? Nothing today can support that. The infrastructure layer that has powered what we know as the cloud today across pretty much every big cloud provider has been Kubernetes. And so I think we need to make that the first primitive for agents. But to do that, you have to make it small. It has to be super dense, instant spin up, spin down. How can we give agents a first-class experience for what does it mean to have its own cloud?
Hi, this is Brian Douglas, and you're listening to Open Source Ready, a bi-weekly series where we discuss the evolution of open source software and its impact on the tech landscape. Along with my co-host John McBride, we'll explore topics like open source AI, the business, and the life and sustainability of open source. Open Source Ready is brought to you by Heavybit, the leading investor of developer-first startups. For more information, visit heavybit.com. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us at x.com/opensourceready. Welcome to another episode of Open Source Ready. John McBride, welcome back. How are you doing?
I'm doing good. I'm hot. There's a heat wave here on the East Coast, but I'm excited.
Okay, thanks for clarifying that heat wave, because when you said you're hot, it is hot John summer, I guess. Or is it a hot IPO summer?
Hot IPO John summer. We declared it here first. Welcome.
Excellent. Well, yeah, a lot of hot things happening. AI, IPOs, SpaceX. But also, we've got a hot guest, Zach Smith. How you doing?
Hey, good to be here with Douglas and John. Hot Friday in San Francisco as well.
Yeah, I was going to ask, how's the mission holding up today? I think this might be the last hot day for a bit for us.
Yeah, I say hot, but it's 75 degrees. Most people would not complain, but
okay, not bad.
It's hot for us here in the mission.
Yeah, I was at a mission last night as one of my infamous founder dinners that you've attended some of these with me, Zach. But it was nice to get the breeze in last night, so it quite cooled off. But speaking of the weather, let's actually stop talking about the weather. Let's talk about what you're working on. We know of you for this little project you kind of started a few months back called Kplane. But before we get to Kplane, could we just find out who Zach is? What's your background? Why are you here?
Yeah, so I've been building developer tools, developer platforms for a little over a decade now, mostly on the Kubernetes cloud native side. So I actually started my career working with a tool called Cloud Foundry, which was a big kind of microservices containerization platform used by a lot of the Fortune 500. And then that, as that phased out, everything transitioned into Kubernetes. And the rest is history. So been pretty deep in Kubernetes, most recently working on things like the multi-cluster runtime with the Kubernetes SIG community. And then, Kplane, figuring out how we can virtualize the Kubernetes API server.
Nice, yeah. And then, can we just talk about Kplane at this point? Because the open source project today, I'm pretty confident our listeners probably have a lot of interest in knowing what this thing is.
Yeah, so there's a couple of, similar or adjacent projects, one of which is called KCP. KCP is a kube-like API server, heavily influenced by the API server, mostly for internal developer teams to kind of stand up a consistent API that their developers are used to and scale them horizontally. There's also folks like vCluster that have been kind of at the scene for a few years now. I think they're Series B or Series C at this point, that are getting lots of success in the enterprise and GPU spaces as well. Kplane is kind of a mix between those where, the world kind of went, if you rewind 5 to 10 years, we had these massive Kubernetes clusters. Everybody was doing multi-tenancy on them. Every customer gets their own namespace. And this pattern is actually very common. I would assume that 80% of the multi-tenancy workloads look very similar to that. Then you get customers who graduate out of that and they kind of slingshot to the other end, which is everybody gets their own Kubernetes cluster. The problem is that you end up having this Kubernetes tax where you have to deploy the control plane, manage the control plane upgrades, you're spending cost on compute and memory and those sorts of things. Kplane is kind of the middle of the road between both of those extremes where we say, actually, we can give you the control plane in a virtualized manner where you don't have to replicate resources for every single cluster that you want to have. And instead, you can share a single group that is also distributed across regions or zones, but have hundreds or thousands or tens of thousands of clusters from that. And so, Kplane is kind of the first step, virtualizing the Kubernetes control plane. And then the stuff on the multi-cluster runtime is kind of the other side of it, of how can you deploy one operator to reconcile resources across many clusters at scale.
Yeah. I think this is really fascinating work from, when I was also at Cloud Foundry, then to VMware working on Tanzu. And that was deeply integrated with Cluster API, which is kind of this whole Kubernetes native way to declare resources, machines, and, et cetera. And I think was some of the groundwork here. So I'm curious, the deeper history on some of the multi-cluster stuff that you've been working with the SIGs. Like, how's that been going? Like, what's the history with that as far as it relates to, maybe where some of our listeners are at deeper in the enterprise, right?
Yeah. So the multi-cluster runtime is relatively newer.
Uh-huh.
It is getting a lot of traction. If you don't do this and you've got, let's say, tens or hundreds of clusters, you have to deploy that operator every single time. And you have to, of course, manage the life cycle of it. Then you get to the question of like, well, is that operator being, fully utilized? Like, what is the utilization of that operator? Is it 5%, 10%? And you've got to like right size it per cluster. Where instead, what people are realizing is that actually, this kind of management plane model, where it's like a centralized management plane, some region out there, but then you've got this like global distribution of clusters that are really just like replicas or edge locations for your kind of core set of resources. You can just deploy this, multi-cluster operator once and have it watch all of those at the same time. And so I think people are saying, okay, we can actually save a lot of just pure compute and resources by doing this model. And it also simplifies like developers' lifecycle where, all the logs, all that, the reconciliation is in one place. You're not fanning out, you're not just pushing them to the edge, you're actually reconciling them centrally. And then the edge just gets the correct status and state that it should have, right?
Yeah.
But yeah, I think it's definitely up and coming. Lots of folks that are building large scale clusters are on top of it. So if you look at kind of the contributor list for that project, you'll see folks from NVIDIA, vCluster, and a lot of different other enterprise companies that are all investing in it.
Totally. Yeah, this is really interesting because I actually was thinking about a lot of this stuff with a recent Coinbase incident. And this was actually one of my reads where, it's easy to point fingers, we don't really know, the volumes and the trading volumes and all that stuff. But essentially they had this huge outage where a bunch of their stuff was like in one region. And I think even one node, like correct me if I'm wrong, Brian, but essentially, that one thing goes down, that one region goes down, and like the whole trading platform goes down. And I was thinking about this because I was like, well, how hard would it be to virtualize some of the resources across, multiple regions, even having like failovers and stuff? Is this kind of similar realm where Kplane plays in or that you think about?
I think it depends, right? I think a lot of companies still have to have like one management plane or at least like an active passive management plane. And I think, for that layer, like it typically does make sense to leverage like the bigger clouds, like the EKS, the GKS of the world, just given the reliability that they bring. But yeah, you should definitely have, multiple copies of it. I think and not saying that like the Kplane or the vCluster or the KCP model isn't, reliable enough, but, it's hard to compete, of course, with those nines of availability. I think it just comes down to that, active architecture that a lot of companies just aren't doing, especially if you just have one centralized management plane.
Yeah. This is something I feel like I have these like kind of crisis of faith moments on where I'm like, oh, Kubernetes is great. I love Kubernetes. I built so much of my career on Kubernetes. But sometimes I really just want like the the breeze and the ease of, like a Cloudflare worker architecture where it's just like, it's a very stateless thing. Granted, a lot of the Kubernetes stuff is very stateless. Maybe control planes end up being where like a lot of the most of that state ends up living, especially in a multi-cluster architecture. But yeah, I find this technology so fascinating because it's so cool that you can virtualize a bunch of those bits to then kind of ease some of that pain, right?
Yeah. And it's funny that you mentioned that, like before the Kplane project, I was actually kind of going down the rabbit hole on why are people not doing global Kubernetes clusters?
Mm.
And it turns out that with Raft, the consensus algorithm used in etcd, it starts to break when you have higher latencies around the world. And so, if you have let's say a normal Kubernetes cluster with 4 nodes and one of the nodes goes down, the pods shift over and everything is typically fine. There might be like a little bit of downtime in between, depending, of course, the replicas that you have inside that cluster. But if you were to, stretch that across a region or say, let's actually do like global footprint of nodes, but still one cluster, yeah, things start to break. And a lot of people have tried this. And what's interesting is that there's actually a couple new algorithms that have been proposed, so like fast raft and hierarchical raft, which would potentially allow you to have this global Kubernetes cluster that could handle a whole region going down, where today, with all the big clouds like EKS and GKS, you have to build that, cluster in simply one region.
Yeah.
So
Interesting stuff, but unfortunately, bigger fish to fry.
Yeah.
I was just going to ask, because why is Google or Amazon not already doing this already? Like these hyperscalers, they're all built on Kubernetes. Is this kind of out of sight, out of mind, or do they have a different game that they're playing?
I think it's also one of those things around, if you mess something up and you have one cluster, you're now down globally.
Yeah.
Right. So it was one of those it would be nice and simple to have a global Kubernetes cluster, but if you push one small config change, you're taking out everything. And so instead, people go, actually, the regional model is kind of a good safety boundary where, updates are pushed to one region first. Everything looks good. They get pushed to the next region, provides you some level of confidence before you push that single config change that takes out all the Windows servers in the world and flights stop, right?
Yeah.
Yeah. They also, I don't know, this is maybe a cynical take, but they don't want to compete with themselves by, having these really great Kubernetes offerings that bring in lots of money because, Kubernetes uses a lot of compute. They do have serverless platforms like Lambda, and I'm thinking of like Google's Cloud Run and App Engine and stuff, which probably have Kubernetes components, but also have probably more stateless, just on raw compute kind of components and stuff. So it's best not to compete with your own products.
Yep, that's true.
Yeah. So, sorry, when did you start Kplane? What's the time frame we're looking at?
Yeah, so a few months back, I was working with some old friends. Their company is called Datum, building kind of an open alternative to Cloudflare. And it's all open source, so feel free to take a look. Their model is, global edge locations. So, I think they're up to 20, maybe they'll be at 40 before we push live. Each of those edge locations is a Kubernetes cluster. And so similar pattern of single management plane, reconcile the resources and then push them out to the edge for networking primitives. And so the problem that, we had was we want every customer who signs up to have the Kubernetes experience of, oh, I have my own API server. I can deploy my resources. I know what a config map is. I know what a secret is. And everything's very familiar, especially to people that are in that infra role at these bigger companies. And so instead of building your own custom API and saying here's the API definitions, go learn this, go learn our new SDK, it was actually no, hey, everything's the Kubernetes API. Just use kubectl, look at the CRDs. You can see what we expose to you. It shows you the specs. It shows you how to use them, etc. And so that was the kind of user experience that we were after. Now, we didn't have Kplane, and for some reasons, we decided to not go forward with KCP. And so the problem was, do we want to spend, $20, $30 a month per project in just underlying resources for every new customer that signs up? And if you have 10,000 of those or 1 million of those, especially in the free tier, it gets expensive really quick. And so that was where we took the first stab at how do we virtualize that API server. Definitely the earlier versions. So I think we got it down to 20, 30 megabytes of overhead per project, which is still a lot better than vanilla, right? You're thinking about multiple pods and deployments that need 500 megabytes of RAM just to boot up. And so ended up taking that, investing it into its own kind of project where we could say, how far can we take this? And how can we make this a real primitive that companies can leverage? And so went super deep, weeks and weeks of profiling over and over, getting it down to one Go routine and refactoring the Informer libraries and the caches to make sure that they can actually do things the right way without breaking the Kubernetes contract. And so I think that's something that we really care about is how close can we stay to what people expect in Kubernetes without making a bunch of our own opinions.
Yeah, you had mentioned Cloud Foundry and that being kind of a beginning part of the journey. I find that so fascinating because, in my opinion, Cloud Foundry had probably one of the best developer experiences, of the early cloud era. Like being able to CF push something and then like the whole build packs stuff. And granted, the opposite side, the operator side was an absolute nightmare with Bosch, and having to upgrade Cloud Foundry is just like a weeks long task. How do you envision that? And you just briefly mentioned also that developer contract, that developer experience. Like, do you see a related, middle ground where, maybe we get closer to a CF push experience with something like a Kplane? Or sometimes I feel that way with Kind, where I'm like, Kind is kind of is closer, where at least I can have this locally and I can sort of start to iterate on things, but it still ends up being a little nasty as far as like kind of breaks some of the contracts of how a real cluster works.
Yeah. I'm so glad that you said the CF push experience, because I also think it was one of the like best experiences for a developer who's even like coming into their career being like, what do I have to do? Like, what is a build? And like, how do I make sure that the image is correct? And like, what does it mean to like install, packages for the image to, before it boots up and all these things? It was like, no, just CF push and you're done.
Yeah.
And it would work like 90% of the time, unless you have some very weird stuff going on in your container. But yeah, to your point, I think Kind is, one of the closer Kubernetes similar experiences where it's like, hey, you're working locally, you want to spin up a cluster, you run Kind and you get one. And so we actually based the Kplane CLI very closely to the experience of Kind. We actually do use some of Kind's internals around kind of the worker nodes and like management plane. I think we actually added support for like K3S as well. But
cool.
Yeah, I think that's the goal, right? Is like, it's so easy, I think, for people to be like, we have this whole new user experience, but then you have to like convince them of why that's better than everything they've been using today. And so rather than doing that, we're like, no, let's just go with what people like and what they know, which is Kind if you're a Kubernetes developer. And then when you use Kplane, it should feel, native and normal.
Yeah. I've been out of the Kubernetes, I guess the core Kubernetes product development cycle for a little while, but is this something that could enable like a whole cluster and cluster testing kind of thing? I remember on Tanzu, we really struggled with this because we were building a Kubernetes product. We wanted to be able to test it in a Kubernetes native way, and that was really hard. So even trying to like run Kind inside of a cluster was kind of a nightmare.
Yeah, I think that's a great point. I think, like CI and testing doesn't get a ton of love, right? Or innovation in that space. I mean, I could say the last like 10 operator repos, the tests take 15, 20 minutes to finish. And so you're stuck waiting there for that PR.
Yeah.
We did take a stab at this as well. It's called Kplane test, which is kind of similar to env test. So env test is like the normal way to test your controllers, where it gives you kind of this like embedded, etcd and control plane. So KCP has an embeddable etcd that we leveraged. And then Kplane is the ability to say, actually, how can we spin up multiple clusters instantly and then have that kind of interaction happen? And so, yeah, that is what we think is like the whole testing experience of how do we make that faster and easier for developers. But I think a lot of people are still stuck on like GitHub Action, spins up a Kind cluster, waits 2 minutes, then it installs all of its operators and controllers and CRDs.
Yeah.
And that's kind of the state of the world right now.
Very cool. Wow.
Yeah. So I was going to ask production. I guess you have a use case for production grade Kplane. I was curious, is it ready for prime time? Like, if folks are listening and they're like, this sounds interesting. Like, is this something they should be shipping?
Yeah. We are dog fooding everything we're building. So in our Kplane cloud, every organization, every project is also a control plane, and those can't go down. Otherwise, you can't do anything inside the cloud. So, I think that a lot of it is, yes, like continuously test, continuously dog food, and get that feedback loop. I think a lot of where we're at is just pushing the limits. So I think right now what we're seeing is that etcd as a backend, you can run into a ceiling pretty quick. etcd has like an 8 gigabyte limit. The API server caches everything in memory. So, as your etcd fills up, your API server is also filling up. And when you've got 1,000 of them, running in one box, you're going to hit some ceilings. And so, what we're looking at is like, how can we, scale a single API server replica to 1 million Kubernetes clusters? And so with that, you have to swap out etcd. There are internal projects at companies like Google, where I used to work, where there was like, can we try like leveraging Spanner as a backend for Kubernetes, or Postgres? I think some folks in the open with Kine have been doing that. Kine is just an etcd shim, right? So Kubernetes actually just speaks to this etcd shim, which then translates it into, Postgres or SQL. But yeah, so that's kind of where we're focused. We've kind of proven out the base functionality, the base like isolation story. All of it is working as expected. We have some customers that are running this in production and others that are onboarding. So it's definitely in its early days, but we're seeing lots of good signal. And yeah, focused on how can we continue to scale this and make it work. When let's say you got one big customer that comes in, like what happens if the noisy neighbor problem? Like how do you help automatically migrate them to their own dedicated API server with zero downtime while starting at kind of that shared multi-tenancy model? So things like that is really where we're focused.
Yeah. You mentioned something there about Kubernetes really being a thin shim, or I guess Kine being a thin shim for etcd, which, is that whole Raft-based distributed key value store. Originally created, I believe, by CoreOS way back in the day. And then Red Hat acquires CoreOS, and a lot of those people were at Heptio as well. Heptio acquired by VMware, VMware acquired by Broadcom. The story goes on and on and on. I wonder, really ever since I was working on upstream Kubernetes, the like maintainability and sustainability of these things. And I'm curious from your perspective, this is a topic that comes up all the time in the podcast, like how maintainable and sustainable are these like really critical, like down at the bedrock of Kubernetes and down at the bedrock of like cloud infrastructure? How maintainable and sustainable are these projects?
Yeah, I mean, that's a great question. And it's definitely not easy. Like you wish it was, your own packages and your own libraries that when you write them, no one else is going to change them.
Yeah.
In this case, it's not. And so, if you look at a couple projects in this space, you often have to fork Kubernetes. And so we tried our hardest to avoid this. It actually got pretty close. The challenge is that, eventually we needed to fork it and make a couple of changes. So that's where it becomes the standard model of like, okay, now we have to maintain this fork. We have to maintain it across versions. And I think for our perspective, it's just like, how do we make sure that we're, making the right changes in that fork so that we're not going to shoot ourselves in the foot in 6 months. But that's going to be a big effort this year is like, how do we put that on autopilot where we don't have to sit there and just bring in 2,000 changes every 6 months, because like that's a nightmare. And so, I think that's where hopefully AI can help with that as well, of like maybe the AI can judge, the complexity of a change and, based on, our changes and like compare them and see it, it will merge cleanly. Like there might be something there of like, let the AI like automatically do these, these syncs periodically. Right. But
yeah,
just a thought,
the not forking Kubernetes bit is so funny because that was like a cardinal sin at AWS. Like the EKS team was, I think that was like a charter, but surprise, surprise, they did and they had to. And I don't think any of them would admit this, but they basically had like a rolling fork that would kind of backfill a bunch of stuff eventually upstream. But I think there were just too many things that they had to basically keep kind of on a rolling forward maintainability kind of track. And they had the resources for that and everything, but a lot would still get upstream. So it's very funny because that is definitely the cycle. That's the cycle you find yourself in with Kubernetes.
Yeah, I think pre-AI, absolutely not. Like, good luck maintaining a fork yourself. Like,
yeah.
But I think now it's like we have the ability to understand the risks and, hopefully speed up parts of that cycle. And so it becomes much more reasonable for a small team.
Yeah.
Definitely still not easy, but it's at least like an option to consider, right?
Yeah.
Yeah. I'll share an anecdote, and I'd love to get your take on this based on this like post-AI world. We were in London for like a couple weeks, and I was staying West London in this like town called Hammersmith. And I learned from like the local news, like the Hammersmith Bridge is like a bazillion years old, and it's like basically falling down. So like out of the 32 bridges, there's like 5 or 6 bridges in London that are basically decrepit. And the reason is because the bridges were never made for semi-trucks. They were only made for like horse carriages. So like everything needs to be retrofitted to like be modernized to like we've had semi-trucks for years, but now it's just like prolific how many like new grocery stores and like every Waitrose and every single department store that needs like semi-trucks to deliver things. So like they have this like epidemic right now for bridges where they have to shut down an entire bridge, traffic gets diverted for like a year, and it's super painful. And as you're talking about this like post-AI world and like what you're building with Kplane, I immediately go to like this story of like bridges are basically falling down in London. We also watched GitHub in Q1, Q2 of this year, like it's still like basically falling down on a regular basis, like lots of degraded surfaces. And it's just the world wasn't really built for this current agent first experiment. So I was curious, like how is like, do you feel Kplane's like really fit for this like new world?
Yeah. What I admire about the Kubernetes maintainers is that they've held the bar so high and so consistently for so long. The challenge, though, as you said, is like at some point you have to come to the realization that like what you have needs to change. And so, that was our perspective of like, if there's billions or trillions of agents and they each, need their own cloud, like what does that look like? Nothing today can support that. Like, the fact that it costs you $70 a month for a single cluster on EKS, like that doesn't scale, right? And so that's where we're saying, okay, how small can we get these Kubernetes clusters? Because if you can give one to every single agent, the story gets very compelling. I think right now everyone's focused on like every agent gets their own VM, agent can then attach storage and, has its own Git file system. We're seeing a bunch of players like, there's 100 new sandbox companies every single week.
Yeah. Well, you get its own credit card as well.
Exactly. Getting its own credit card. And so that's where we say, okay, the infrastructure layer that has powered what we know as the cloud today across pretty much every big cloud provider has been Kubernetes. And so I think we need to make that the first primitive for agents. But to do that, you have to make it small. It has to be super dense, ephemeral, instant spin up, spin down. And so I think that's where a lot of our focus is for our cloud offering is like, how can we give agents a first-class experience for what does it mean to have its own cloud?
Yeah, powerful.
And no dig on the VM guys. Like we are probably going to end up using some of them for our own compute.
Yeah.
But it's just one of those interesting things of like, I feel like we're seeing a lot of people have to like solve the problem that was solved 10 years ago.
Yeah.
Of like you're orchestrating a million VMs and you have your own custom implementation of how to do that. And then everyone realized like, wait, Kubernetes like solved this very well for like every big company that had massive infrastructure. And so I think people will come to that realization, and then hopefully it's not as scary as it was 5 years ago where you had to like learn all this yourself and like memorize the APIs, where it's like, no, actually AI is really good at Kubernetes. Like it has a massive corpus of data that it's been trained on from like a decade plus. I think that it just becomes a very natural fit.
Yeah, amen. I love the I think it's KubeVirt project, which is kind of like the full circle back to Kubernetes managing fleets of VMs.
Yes.
And you could plug that into like a hyperscaler or cloud provider or your metal boxes or whatever. But yeah, just the corpus of information that you get deterministically out of Kubernetes as well is very powerful for agents. Like agents know how to use kubectl, know how to like interface with the resources and all the bits and bobs that make Kubernetes work. So can get good information out of there faster than I would be able to. So it's quite a powerful operator tool in that.
Yeah, there's a good model there as well around like zero trust, as much as I am not a big security guy. But, if you have a bunch of agents on your team and your developers are interacting with like a Kubernetes cluster, now you've got like hundreds of agents, like it can be kind of scary to give that agent access to your Kubernetes environment, where like another option is actually like spin it up its own control plane, put the APIs that you have in there, and then just replicate those back over to the management plane. So like the agent is just interacting with what it believes to be its own cloud. It has no access to like the core critical system. And then of course you just have some simple replicator controller that goes, okay, agent did some work. Let me replicate that back over, to the core management plane with policies and resources in place to just be like, don't give the agent, core access, give it its own access. And then you can evaluate things kind of on the fly.
Yeah.
It's kind of a pattern I think I've seen come up more recently of just give it its own control plane.
Yeah, well, Zach, I do want to transition us to reads, and thank you for the conversation on Kplane. I think it's going to actually relate to a lot of our reads as well. But folks, if you haven't already checked it out, Kplane's on GitHub, also kplane.dev. If this is all interesting, I don't know if there's a sign up. I guess you could start, maybe just start there and then you
start the repo.
Yeah. Cool. So, question for you, Zach. Are you ready to read?
Yeah.
Read.
So, one read I actually wanted to talk to based on the last thing you had mentioned around these sandboxes. Prior to sandboxes, we had this world of frameworks like the LangChains, the Crew AIs, and a former Llama Index employee, actually the CEO of Llama Index as well. He had a blog post that he had wrote around their transition from building Python frameworks to build AI and agents to now essentially what Lori also shared, because he's now at a new company called Arise. The focus is now on harness management and harness building. And I think all these folks are eagerly transitioning into something that's going to be, I guess, have more teeth and moving forward beyond 2026. So I put a link in the show notes, but it kind of goes through that and how they had a pretty good time with the Lang refs. But it's very clear that folks are realizing that there's something new cooking and it's been around for a year. It's their harnesses, like Cloud Code example. But I'll pause there. John, do you have any thoughts on this this note from Lori?
I do. I think it's a pretty bad take. It's not that harnesses are going to take over everything. I agree in the fact that, maybe, company who is trying to just get AI bot to go read some, data lake thing to then tell some executives here's how the revenue is doing. I don't know. You probably don't need a whole LangChain pieces of that. But there's bits and pieces of LangGraph and the composability with tools from SDKs and libraries that is really powerful. Ultimately, it's an SDK and it's a whole code paradigm to go in and build an agent and stuff. And that's honestly way more powerful than I think you would ever get from just the harness. Or they'll start offering these things as bits and pieces that can just plug in. I've been using Pi for a while now, and Pi has a great ecosystem of plugins that you can then tool into the whole turns that it does with the inference provider. So maybe not everything is absolute, but I'd be shocked to find if nobody wanted SDK based things. Maybe the real hot take here is that these are just bad businesses and that, an SDK was never something that was going to generate a ton of revenue. So harnesses integrated deeply with the inference providers. Sure, the inference providers then get revenue based on, tokens that you spend. I'll pause there.
Yeah, Zach, are you using any LangChain today?
No, I am not the biggest fan of that vertical of tools. I'm more of a do it yourself, and do things incrementally as you need to. I think a thing that you see a lot is you adopt something like that that's still very early. And it's a lot of opinions that you have to figure out if you need.
Yeah.
And then what happens if they don't offer something? Do you have to upstream it? Do you just find the wedge and customize it yourself? And so I've been just in the boat of do it yourself. There's lots of very lightweight control loops that you can just build yourself. And yeah, so I'm more of the roll your own, do it yourself rather than, take something like a LangChain and try to figure out their opinions.
Cool. I'll move on to the next read I've got, which is a paper for meta harnesses. This is actually, it's interesting because if you want to kind of find out where the industry is headed, there's a weekly Wednesday paper reading that hosted by the Latent Space podcast. And I feel like every paper that gets shared there, maybe most papers that get shared there is this huge revelation for the entire industry and everyone writes a blog post on it. This is one of them. But actually, I really enjoyed this one, which is about meta harnesses. So this is the harness, the concept of having, I'll go to Cloud Code because Cloud Code's probably the most known harness to kind of really shaped up what future harnesses look like or the current state of harnesses look like. But the idea here is you have a meta harness to basically, instead of leading into skills or leading into fine-tuning models, what they were able to do is lean into fine-tuning the harness. which kind of leans into what Lori was kind of talking through about the future, where he sees the future going. And this is a paper built on that. And I'm going to go ahead and go on a limb and say, like, a lot of folks read that paper and have written blog posts in response to it. But I've been reading this all day, all week pretty much. And I'm like trying to digest it for nuggets of wisdom. And I'll take a step back and think, I spent a lot of time trying to fine tune a model, specifically the low parameter models. And when I came to the conclusion is like skills, you'll get the best bang for your buck today. It'll be cheaper just to write a skill. But their take is like, if you just start adding to your system prompt and adding to your harness, you could probably also get some pretty good mileage for like very bespoke things. And they go through a couple of different examples of like Haiku and it outperforming, like basically double the performance of just using base Haiku with the quad code, which, yeah, I'd love to experiment with this. Probably experiment with this this weekend, but that's pretty much all I got for the read.
Yeah, I think I agree with that take. Is like there's still a lot of alpha in a good system prompt, right? Like take the same model, but someone that has a really good system prompt will likely get better results. I think we just saw yesterday, like the leak of the Claude's latest model, like its system prompt is like 112,000 tokens or something like that. Like it's massive.
Wow.
And so, I think that's interesting. I think another piece that's interesting is what you said earlier of like fine-tuning your own model is kind of still expensive and it takes a little while, like, maybe a few hours, depending on which algorithm you're using. But I'm wondering if like the trend there will continue growing where the fine-tuning becomes something that could happen in 5 minutes or 15 minutes.
Yeah.
And cost you pennies, where it's like, wait, if you fine-tuned it on, let's say, a specific code repo, like, will the accuracy go up? Do you even need to like have all that effort in the system prompt if it already has like weights that are like adjusted to the latest changes in the repo? I think that's where my don't go to sleep at night is like, yeah, which one is going to win? Is it going to be people that like fine tune the latest Chinese model because it's better at coding, or is it going to be people that are like focusing on the harnesses and the system prompts and all of those types of things?
That's a good question.
I lean towards folks who don't mind rolling their sleeves up and like really touching the tools. Yeah, I think it's like a good mechanic is probably going to have like the best longevity of a car, like going to get the best juice out of the car, like long term. I think it comes down with that. Like if you're not a mechanic, you're probably going to reach for the easier solution or probably just go with foundational stuff. But maybe bring back like, let's open up the hood and look at this stuff and try to reverse engineer things again.
Yeah. I find this interesting because a lot of the harnesses, even still today, are ultimately like a feedback loop. Goes out to the inference provider, comes back, those conversation turns, and then it presents a few tools to the model that it can use, like a read tool, a search tool, a bash tool, et cetera. And it always seems so arbitrary and kind of broken whenever I see it, like, Opus 4.8 or whatever, Fable, heck, using riprep, I'm just like, that's not going to be great for you. I already know, and I can see you trying to use riprep in this very like kind of crazy way. And like, that's not going to give you a ton of code that I know that you probably want to go find. It'd be better if there was like some very AI focused chunking tool or search tool or something that could, expand the horizon a little beyond just like a regular expression. So my hot take here is actually the Astral team being acquired by OpenAI, basically landing on the Codex team. I would just love to see Codex more deeply integrated with UV and like little Python capabilities and things, because that would be a powerhouse. Like really the meta harness of the harness, I guess, itself, or the model inside of the harness or whatever, being able to like morph and mutate and like create this kind of liquid tooling that is just Python based to be able to do more powerful and interesting things. Yeah, the future is going to be wild. We'll see.
That's cool. Excellent. John, you got a read for us?
Yeah, I mentioned the Coinbase one. I have another one that I especially thought Zach would find interesting, which is this thing that Apple announced at WWDC, which is Apple Container Machines. And this is something Apple, I think, has been working on a long time. The whole like idea of an Apple container is basically like their native approach to lightweight Linux containers natively on Mac OS. And now they have kind of the whole idea of essentially like a fast, lightweight, persistent Linux box. And I believe what it's plugging into, after kind of digging into it, is actually Apple's virtualization framework under the hood, which is their kind of native hypervisor on macOS, which is a little different than how some of these others have approached it. Like I know OrbStack built kind of their own native VM. I don't know what Lima is doing. Obviously, Docker has its own like virtual machine, which is quite heavy and stuff. So I think this is awesome. I think it's very cool that Apple is kind of dipping its toes a little bit more into the like native Linux capabilities that, well, I guess macOS is Linux anyways, but more Linux, right? Zach, did you see this come about?
I did not, but I think this is pretty cool. My first thought goes, can we get containers that are still running like OS X and like Mac OS? Because in the testing world, like it's actually so hard to get like remote Macs.
Oh my gosh, yeah.
Like still to this day, and I'm just like, can we solve that through this? Maybe like maybe that's an angle because like you said, if it's running on their virtualization technology, like maybe it will be super easy to just have a bunch of Mac containers now.
I would love that as well. I think it's so sad that OS X Serve or whatever that thing from like the 2010s is gone. Maybe it could be Tim Apple, or I guess whoever is now over here. If you're listening, please give us Mac OS as a container that we can run somewhere.
Yeah, like the new CEO is John, because I think it was like Johnny Apple was going to be the new pun. But I originally went to like this whole like the run on the Mac Minis with OpenClaw, and like that sort of like clustered everyone, like literally a cluster that everyone was put together for like spinning up their agents. And yeah, the sort of like the run on compute, but also like if you could virtualize that stuff. I think it's bright for Apple. I think bright in the sense that they're taking a step back into the world that they kind of ignored with the prosumer stuff, or the focus on the prosumer kind of ignored all this like server things.
Yeah.
I worked at GitHub, and I specifically remember when we sourced a bunch of like Mac OS machines to do Mac OS runners for GitHub Actions. And like the screenshots or the actual pictures of the actual room with the trash can Macs, like that's literally how it was solved. Is like we just had like a cluster of trash can Macs in a closet.
Yeah.
And that was how you could get Mac OS runners or GitHub Actions back in 2019.
Wow, it's wild. The other crazy thing about this to me is it's all written in Swift, server-side Swift, which I know has been kind of an up-and-coming thing, not just for like your apps on an iPhone, but yeah, pretty wild how some people have been saying it's performing. I tried it out a little bit, nothing too heavyweight, but Swift, it's happening.
That's cool. Yeah, I mean, apparently people are saying that it's faster than Docker. So like, I'd be curious, like if people are going to actually start switching over and saying like, we're just going to run this instead of Docker from here on out. There's also probably like a cost angle there too. Like, if you get big enough, you have to start paying for Docker Hub on all your developer machines because you have a team that's too large. Like, I wonder if this is like an angle to be like, actually, we don't have to do that anymore.
Yeah.
We're just going to use containerization.
I think that's been the case for a little while. Like, I even remember when I was at Amazon and they were working on like Nerd Cuddle and a bunch of those other like, I forget what, there were a few of these that were like, well, we're not going to pay for this, so let's just build it ourselves based on Containerd.
Nice.
Yeah, build versus buy is a real thing, especially in the world of agents and being able to take control. Or let your agents take the wheel.
Let your agents take the wheel.
Yeah, agents take the wheel.
Show title. Excellent. Well, hey, Zach, thanks so much for the conversation and going through some reads with us. Folks, again, if you have not checked out Kplane at this point while you're doing your commute and hanging out on the BART train, check it out. Kplane dev on GitHub, kplane.dev on the internet. And listeners, stay ready. That's all the time we have for today. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us at x.com/opensourceready. Open Source Ready is brought to you by Heavybit, the leading investor of developer-first startups. For more information, visit heavybit.com.